What's up, scholars? In this video, we're going to be solving logarithmic equations. So I have written here three of the major rules whenever we're dealing with logarithms. And you already saw these earlier this week, but if you don't already have these next to you, I would suggest having these written out somewhere next to you as we work through. You have the product rule, which is basically if you have two things being multiplied, the product of these two things, and you're taking the log of those, you can rewrite that as the addition of the logarithm, same base. Notice that the base hasn't changed. Logarithm of that first thing that you are multiplying plus the logarithm of that second thing that you are multiplying. Really, really handy rules to have. The other thing is the quotient rule. Whenever you have uh, a number divided by a number that you're taking the log of, you can rewrite that as, notice the numerator on top comes first minus the log of the thing that was in the denominator. And then lastly, the power rule. This is used all the time. I might do an example first with this particular rule. The power rule just basically states, if you're taking the log of the base of something to a power, you can bring that power down in front as a multiplier. And that basically works because a logarithm is a power. A logarithm is an exponent. That's going to take you a little while to wrap your head around that sentence, but say it to yourself in your head as though you were in the military, all right? A logarithm equals a power. A logarithm is a power. That's all it is. Now, I do have this other rule over here, and this is like one of the most, if not the most important rules in logarithms. And this is like your rewrite, right? This is also what I refer to as the circle of life. And of course, we call it the circle of life because we say the base to the power of x here equals a. And so this makes like a little circle right here, right? Notice the logarithm equals the power, all right? A logarithm is a power. This whole thing equals x. And so here it's b to the x. The x is the power, all right? We're going to be getting more into functions where x is the power a little bit later. There's one other rule that I don't think you have seen this yet, and it is the equity rule. Oh, that's funny. I just said equity. It's actually called equality. Do y'all know the difference between equity and equality? Like in this day and age, we should all know the difference between the two. Real quick, the difference between equity and equality. If let's say that I'm trying to go to, let's say I'm trying to go to a football game at our high school, right? And right now, because it's COVID, I have to stand really far away and there is a fence in the way. Now, you don't know this because we haven't met in person, but I'm pretty short and I can't see over the fence. I'm also at the football game with my BFF, which she's a little taller than I am. And also, I brought my dad along with us, which he's huge. Like, absolutely, the man is freakishly tall. So none of us can see over the fence, all right? Equality would be like if we were all treated the exact same way, if we were all treated equal. So in order to see over the fence, we were each given a step stool that was maybe just this tall. Okay, so give that step stool to my dad. He'd be able to see over the fence. He'd be able to watch the football game and enjoy his time, right? But my BFF wouldn't quite make it, and I definitely wouldn't make it. I would be asking her if I could, get a piggyback while she stands on this thing and to just suffer through it, right? That would be equality. Equity would be the fair thing to do. I don't even know what to write here for equity. Equity would be like, my dad gets this step stool because that's what he needs. Then my BFF would get a taller step stool because that's what she needs. And I would get a seriously tall step stool because I need some real help in this issue. Look at that, step stool is like taller than I am. That's funny. Anyway, the difference between equality and equity, everybody, you should know this. All right, back to logs though. The equality rule, I don't really know, is this equitable? This rule basically states that if you're taking the log of one thing on one side and a log of another thing on another side, and both the bases are the same, notice it's both b, right? So this is like base 10 or base e, it doesn't matter which base you choose, as long as the base is the same, then what's inside the logs just equals each other, all right? Another way to see this is whatever I do to one side of the equation, as long as I do the same thing to the other side of the equation, then both the balance stays on each side. Anytime you're solving an equation, anytime you do something to one side, you have to do it to the other. That's kind of how this works. So let's look at some examples using all of these rules. Whenever you're solving logarithmic equations, you're only going to see them in two types, right? You're going to narrow them down and simplify them into these two kinds. You're either going to get a rewrite or you're going to get a log equals a log, all right? And that is it. Those are the only two ways that you can get an equation down to something. Let's just say you have log base 2 of x equals 4, all right? I look at that and I go, I have no idea what's really going on. So I'm going to use the circle of life, right? And I'm going to rewrite this. This basically states 2 to the power of 4 gets me back to x. So I'm going to rewrite 2 to the power of 4 equals x. And then we just do that multiplication, right? So this is 2 times 2 times 2 times 2. If you don't know this right off the top of your head, not that big of a deal, right? But you might want to think about writing out a couple of basic numbers like 2 and 3 and maybe bring them up to like powers of 5. Having those memorized is really, really nice in this case, or just written down so you can quickly reference them, write them down underneath all of your log rules. It's always great. So 2 to the power of 4 is 16 and x equals 16. In this case, we have a log equals a log. So that means that, and they have the same base. So that means that I can just drop the logs and just say whatever's inside those parentheses equals whatever's inside the parentheses on the other side. So this automatically becomes, and now it's really easy to solve for x. In my mind, I think to myself, I've already got a number on this side and x is on this side. I might as well subtract 2x from both sides first. And now divide by 3, and you can see that x equals 3. How about something like this? Well, I do see that I have log of something equals a number, right? But it's not quite simplified enough, right? So up here, it's just the log with the base and the thing, and I can do the circle of life. But over here, I've got this multiplier of 2 out in front, and I got to take care of that. Now, there's two things that I can do. This 2 is just being multiplied, right? So to undo multiplication, I can do division, or I could use the power rule stated over here, where if I have this multiplier out in front, I can bring that up to be in the power of whatever I'm taking the log of. I'm going to do it both ways. First, I'm going to do it the easy way because I noticed that if I divide both sides by 2 to cancel that 2 out, when I come over here, 0 divided by 2 is still 0. So it gets really easy for me. Log of negative 2r equals still just 0. And now I'm ready to use my rewrite. Let's do the circle of life. This is a base 10. So 10 to the power of 0 equals my negative 2r. Anything to the power of 0 is 1. And now I can just divide by negative 2. And r equals negative 1/2. All right, cool. But what if I had used my rule over here, my power rule? So let's just give that a try really quick. The power rule states that if I have something out in front as a multiplier, I can just put it up in the power of the log. So I'm going to bring this thing and stick it up here and make it part of the power. I'm going to rewrite this as, and everything that I'm taking the log of needs to be raised to that power. Okay, great. Here we go. Now I'm going to use my rewrite rule again. Bring it down here so we can see it. My rewrite rule, 10 to the power of 0 gets me back to negative 2r squared. Ooh, watch those parentheses. I want this 2 to see everything that's in here. So now, anything to the power of 0, right? Now, I could have done negative 2 squared and then r squared, but I'm still going to have to solve for that r squared in the end. So I figured I'd leave it here and just get rid of it now. So how do I undo a power of 2? Take the square root. And whatever we do to one side, we do to the other side. That power of 2 undoes with that square root, and I get negative 2r equals the square root of 1, which is just 1. And now you can see, oh, no, you can't see, literally. Now you can see I divide both sides by negative 2, and I get r equals negative 1/2, which is what we got up here. So either way you want to go with that one, it's going to work, whether or not you just want to isolate the logarithm by itself and do the rewrite, or you can use the power rule and bring that multiplier of 2 up and then do the rewrite. Let's try one with the product rule. All right, here we go. Now I have this, I have a big plus sign here. These bases are the same, so I can use my product rule. If two logs are being added with the same bases, whatever they're taking the log of, I can just put those in parentheses and multiply them. So here we go. And I could have written this as log of 8x, which would actually be prettier. So I might just switch that around in the next step. I don't know. But now that we've done this, now we just have a basic rewrite again, and we're just going to use the circle of life. Okay. So this is 10 to the power of 2. Gets me back to 8x's. And now what is 10 to the power of 2? And divide by 8. And x equals 25 halves. Now I could like write this as a decimal, but usually in mathematics, we just leave it as a fraction and it's all good. Let's try one that's not so pretty and uses natural logs. So also, just real quick, notice I put parentheses around this 2 right here. If you just have one number, sometimes you'll notice people don't write the parentheses. It's usually good form to write the parentheses, but I constantly see a lot of worksheets and things that don't have parentheses. So don't worry too much about that. It's only when you have like multiple terms or something is both of these things need to be raised to a power or something like that, you really have to put the parentheses. Otherwise, this would say the natural log of 3x, that whole thing, plus 2. So here we go. This has a nice minus sign in the middle. So I already see right off the bat, I'm going to use my quotient rule, and I'm going to put the thing that comes first in the numerator and the thing in the second term in the denominator. Now in this case, I don't even necessarily have to put parentheses around this thing because there's this big fat division bar right there, but I'm just going to put parentheses here for good form and make it really obvious. Also, one quick thing to note, there are no rules here which show a plus or a minus sign inside the parentheses here for the logarithm, right? They're only outside between the two. There's nothing where they're like inside. So be careful. Don't try to rewrite this whole thing as, like a product rule or something like that. It's a common mistake. I used to make it sometimes, and I still look at them and go, wait, what? Can I do something? But no, you can't. You can't do anything with this. It just stays as that. So now recall the natural log is log base e. So this is just a rewrite in disguise. So I'm going to have e to the power of 1 gets me back to what's inside. Sweet. And anything to the power of 1 is just itself, right? So this is just really like the number e equals all this stuff. So this is just a decimal. This is just some number that's stored in your calculator, right? You don't have to worry too much about it. But let's just solve for x. X is in the denominator, and I do not like things in denominators, especially big things. So to undo division, I'm just going to multiply. What do I multiply by? By everything that's in the denominator that I want to move out of the denominator. So bam, that gets multiplied both sides. Those cancel. Whew, it's gone. And 2 now equals e times both of these terms, right? So I just distributed the e throughout here, and I'm going for x. I'm trying to solve for x, right? So I want to get x by itself. This 2e is just a number, all right? So I can just move it over to the other side. I'm just going to move everything over to the other side. So I'm going to minus 2e, minus 2e, bye-bye. And again, these are just numbers. You could like type this into your calculator and get a decimal, but we're just going to leave it as e's. Just remember, it's just some crazy number. So now, whenever I have x times some crazy number like 3e, I'm only one step away from getting x by itself. And x equals 2 minus 2e over 3e. I have no idea what number this is. Absolutely no idea, right? I know e is 2.7 something. So this is, 2 times 2.7 something, it's bigger than 4, right? So you're going to get like a negative number on the top, and it's going to be negative, whatever it is. It doesn't really matter what the number is. This is the exact answer, and we got x by itself. It's pretty cool that we could do that. Don't worry, I'm not going to give you one quite as difficult as this on the quiz, but you will have to solve for x in a natural log form. All right, so boom. So how about this one? There's lots of logs going on, right? I see logs on this side of the equation and logs on this side of the equation. So when I set this up, I think to myself, I'm probably going to have to use this where it's like a log equals a log, and then I can just drop the logs and just get, what it stuff equals stuff. No more logarithms. But first I got to clean it up. I see this minus sign right in the middle and that jumps out and I'm like, boom, quotient rule. So I'm going to rewrite this. Remember, I checked to make sure that the bases are the same, and they are. So we're golden, and the bases are the same all the way across. So we're really good. Also, the first term is going to be in the numerator. Second term is going to be in the denominator. Of course, pause the video anytime you want and see if you can give this a shot. All right, so now, yes, we have what we wanted to have, which is log equals a log. And so since they both have the same base, I'm just going to drop the logs and just say all this stuff equals all this stuff. Now, to get x is in the denominator. I hate denominators. I'm going to get rid of, well, I shouldn't say hate, but it's not pretty like I want it to be. Let's make it pretty. Bye-bye. Here we go. Oh my gosh, this looks like a crazy one. Okay, so now I'm going to minus and one step away from solving for x. A lot of fractional answers today, kind of funky, but it's all good. That is it, and that is all there is to it. You are basically trying to simplify things using these rules, and then you're trying to get it into one of these two forms. It's either going to be a rewrite where then you can see the answer, or it's going to be a log equals a log, drop the logs and solve for x.